I want to talk about graphing lines from slope-intercept form, and we're going to start working with lines with geometry. Now, slope-intercept form is the most common kind of beginning way to graph lines, and it is always set up as y equals mx plus b, where m is our slope, okay, because every time x increases by 1, every time we multiply by a new x, x equals 1, x equals 2, x equals 3, we multiply by the slope to say, well, how much did we increase or decrease based on x moving? And b is the y-intercept. It's where we hit the y-axis. And the reason that, works is because if x were 0, anything times 0 is 0 plus the y-intercept. So, x, of course, is left to right, this horizontal axis. So if x is 0, we just go to the y-intercept. It's where we hit the y-axis. So let's just do a couple of quick examples. Let's say y is equal to 2x plus 1. So I would start with the y-intercept. In this form, I would always start with the y-intercept. And again, that's what happens when x is 0. So 2 times 0 plus 1, it's always this number. It's just 1. So I'm going to put a little thing on that point where x is 0. The y-intercept is 1. And then the slope is 2. Now, how I think about slope, there are a couple ways to do this. I always think, okay, for every time x goes up or goes over 1, we should go up 2. So, for example, go over 1, go up 2. So here's the next point. Go over 1, up 2. Here's the next point. And then we could just connect those, like this. And that's my line. Now, another way you could think about it, because a lot of times people think of slope as, write m equals rise over run. So we went, our rise was 2. Think about 2 as a fraction is 2 over 1. So our rise, we went up 2 over 1, up 2 over 1. So rise over the run. We went up 2 over 1. Let's do another example. Let's say y was equal to negative 1/3 x plus 3. Okay? So again, I'm going to start with the y-intercept, which is 3, because again, remember, it's when x is 0. So negative 1/3 times 0 plus 3 is 3. Now, you can think about slope in both ways that we talked about in the first example. For example, you could say, well, if I go over 1, I should go, because of this negative, I should go down 1/3. Go over 1, down 1/3, over 1, like that. Or you could think about it this way, rise over run. And what I would always do is I would just think if you have a negative in front, apply it to one of them. Just say like, okay, it's going to be like that. You could also do it on the -3, but I think it's always easiest to do it to the numerator. You don't apply it to both, because if you did a -1 and a -3, well, then you made it positive, because a negative divided by a negative, you just lost your negative sign. So if we can think about it this way, rise over run, well, a negative rise means you went down 1 and over 3. So, down 1 over 3. Down 1, 3, like that. And then we could just connect those. And there's our line. Okay. Let's do one final example. Do y equals 3/5 x minus 2. And maybe you want to think about this like, it's plus a -2. But the y-intercept this time is -2. When x is 0, again, just the way to remember this is always, it's if x is 0, this whole piece would be 0. So you went down 2. So when x is 0, we're at -2. Now, again, you can think about it as, okay, for every 1 x I go over, I go up 3/5. But I think in this case, it's going to be easier to use this kind of definition, that, the rise over the run, how the y changes divided by how the x changes. So we went up 3 and over 5, so up 3, and then over 5, like that. And that's going to actually be all I can even fit on this graph. And then I would just connect those like that. and there's my line. So again, I would always start with the y-intercept, put this along the axis when x is 0, and then use the slope, say, okay, it's the rise over the run, or the, for every x, what happens in the slope. Here for every x I went up 2, here for every x I went down 1/3, here for every x I went up 3/5, or you could map it as I went up 2 and over 1, I went down 1 and over 3, I went up 3 and over 1. If there's a negative on front of the slope, just apply it to either the numerator or the denominator. I would usually recommend the numerator. If this helped you, please like and subscribe. I make content all about different math topics, and if you need more geometry help, please check in with my geometry playlist. Have a great day. Really enjoy it.